Okay, so this is section 4.6 on the quadratic formula, which should be a little bit of review. And the quadratic formula, you should be able to check and solve, even on the test tomorrow. If you couldn't get one by factoring, you could work it by the quadratic formula and work your way backwards. So this is another method to solve quadratic equations. So this is on what they call the quadratic formula and the discriminant. Should have had this in Algebra 1 a little bit. First, there's a difference between the quadratic equation and a quadratic formula. Ax squared plus bx plus c equals 0. This is the quadratic equation. It's what they call standard form equal to 0 of the quadratic equation. And if I had you graph it, all I would do is change that 0 to a y and then graph it. Okay, from there we're going to complete the square and get the quadratic formula. So if we were in this form and we completed the square, just like what you did on today's assignment, you would divide by a on both sides. Okay? And we're going to do it in terms of the variables instead of numbers. That a divides into each term, so you'd have x squared plus b over a x plus c over a equals 0. Then you take the constant term over to the other side. So we're going to subtract c over a. And when I do that, I always leave a space. So I'm going to have x squared plus b over a x, leave a space, equals the opposite of c over a. Next step on completing the square is take half the coefficient of the linear term. So you take half of that. So half of means what? Multiply. Half of b over a. So it's just b over 2a. And you add the square of that to both sides. So add b over 2a quantity squared. Okay? That completes the square on the left side. Makes that a trinomial square. X squared is a perfect square of x. B over 2a squared is a perfect square of b over 2a. This tells you the sign inside's plus. Factor it back into the square of a binomial. Equals. Now, you got to do a little bit, and I would do the arithmetic out at the side. So I have a negative c over a. When you square that fraction, you square the top part, is b squared. Square the 2, which would be 4. Square the a, which would be a squared. Common denominator is 4a squared. So this fraction is going to stay the same. Okay, and you have to say, what did I multiply this by to get this? 4a. So I got to multiply the top by 4a. So that's a negative 4ac. Okay? So we would have, and I'm going to go ahead and combine it the way they would in the formula. They would be b squared minus 4ac over 4a squared. All I did was rearrange the top terms. So this is b squared minus 4ac all over 4a squared. Okay, now you need to get rid of this squared. Take the square root of both sides. And when you do that, it goes over the whole thing. Okay? Top and bottom. Okay, all that's going to do on the left side is it's going to get rid of that squared term. So you'd have x plus b over 2a equals. When you take the square root, you're considering positive or negative. You cannot take anything out around a plus or minus sign. So the top part's just going to stay b squared minus 4ac. But what can I take out of this? Okay. 2a, right? I'm going to take that out on the next line. I'll take it out on the next line. So I'd have x plus b over 2a equals plus or minus. Top part stays b squared minus 4ac, but out of this I can take out 2a on the bottom. Now solve for x, bring this term over to the other side, subtract it, so we'd have x equals the opposite of b over 2a plus or minus the square root of b squared minus 4ac, and it's all over 2a. Okay, so you'd have x equals, they both have the same denominator, x equals the opposite of b plus or minus the square root of b squared minus 4ac, and it's all over 2a. And that is your quadratic formula. You get your quadratic formula from the quadratic equation by completing the square. Okay? So that's your main formula for the quadratic. This one is the quadratic formula. And you can go online, there's several songs online. If you just type in quadratic formula song, Adele's Rolling in the Deep is one of them, Pop Goes the Weasel's another one. So there's different ones. Okay, but this is the main formula. So if you want to check any problems tomorrow on quadratic or you can't get them factored, go to this, get your answers, and work your way backwards. Okay? Okay, I want to go through a couple of examples. Say they give you, and just say solve. X squared minus 3x plus 9 equals 0. When they say solve, what you're really solving for is where does this graph cross the x-axis? Okay? There's got to be two answers for every one of these. Okay? Or if it's a double root, that's a possibility. Okay? So, let's say you had, the first thing I would do is I'd get it in this standard form equal to 0, and I always write out the side. My a would be understood to be 1. My b would be negative 3. And c would be 9. And I'm a firm believer, if I can do one thing for you as a math teacher, is to get you to write the formula down first. So, x equals the opposite of b plus or minus the square root of b squared minus 4ac, and it's all over 2a. When as a teacher grading these, the most people miss the most points because they try to sub in and simplify all at the same time. First step ought to just be, after you write it down, just sub in. Don't do any simplifying. So you'd have x equals the opposite of b. So it's the opposite. So don't simplify it. Just sub in first. Okay, then do the 3 on the next step. Plus or minus. Okay, and then negative 3 squared minus 4. A is 1. C is 9. Extend that square root out, and it's all over 2 times 1. Okay, subbing that in. Hang on. Okay, subbing it in. Now simplify. Okay, so on this step, we'd have x equals. So opposite of negative 3 would be 3, plus or minus. And if you use a calculator on that, remember a negative 3 squared, you got to put the parentheses on it if you use the calculator. Negative 3 times negative 3 is 9. Minus 36. It's all over 2. Okay, then x equals 3 plus or minus 9 minus 36. Yeah, negative 27. All over 2. Okay, and then split that up. So we'd have x equals 3 plus or minus negative 1 times largest perfect square inside there. 9 times 3. It's all over 2. Okay? Keep going. X equals 3 plus or minus. I can take out I and a 3. So plus or minus 3i, radical 3, and it's all over 2. And that's your final answer. So one step at a time as you're going through. What this is telling you is that it's a complex root. So if I graph the parabola, it is not going to cross the x-axis. Okay, I want to go through the discriminant. If you look at just the discriminant is this part right here, just without the radical. Okay, so just the b squared minus 4ac is what they call the discriminant. The radical is not on the discriminant. It's just the part underneath. This is called the discriminant. You can tell what your answers are going to be like, whether they're real, whether they're rational, irrational, imaginary, by looking at just the discriminant. If you looked at just the b squared minus 4ac, look at this. If I look just at that value, square root of a negative, you know it's going to be an I value. It's going to be a complex root. Okay, there is a table in your book. Look on page 268. Page 268, we're actually going to put most of that table in the notes. If you look at the discriminant and find that value, okay, you look at page 268 in your book. I need 3 columns. I want the value of the discriminant. I want the roots, and then the graph. First, if you just sub in to the b squared minus 4ac, if the b squared minus 4ac is greater than 0, say you got 31 for your answer. 31 is greater than 0. Okay? I don't want that one. I want one more. And it's a perfect square. So let's say I got 49. 49 is greater than 0, and it's a perfect square. If the discriminant is a perfect square greater than 0, you're going to have 2 real rational roots. That means your graph is going to look like this. It's going to cross the x-axis at 2 points. Whether it opens up or down on one side, it's going to cross the x-axis. Might open down like that, crossing 2 points. 2 real rational roots. So that'd be like, say, 3/4 and -1. Those are rational numbers. Okay? If you look at the discriminant and your b squared minus 4ac is greater than 0 and not, double underline that, not a perfect square. So let's say my first example was 31. 31 is greater than 0 and it's not a perfect square. I'm going to have 2 real irrational roots. I should give you an example. Like up here I might have like 3/4, isn't it? Like x is 3/4 and x is -1. Those are rational roots. On irrational roots I might get something like this. X equals 5 plus or minus radical 3. Okay, radical 3 is an irrational number. Okay, it's still going to cross. I can still find the decimal value for that. It's still going to cross the x-axis 2 places, you know. So it's still going to cross 2 places. If I look at the discriminant and I sub into the b squared minus 4ac and I get it equal to 0, then my answer is 1 real rational root. Sometimes they call it a double root, a double real root. An example might be if I said x equals 3 and x equals 3. We said that means that the graph's just going to touch the x-axis in one point. So like if I had, it's just going to cross at 3. It's just going to touch at one point. It's not going to cross, it's going to touch. And I could have a negative number that's so like if I said negative 3. Okay? But the roots are the same number. Okay? Last possibility is the one we just did on the example. B squared minus 4ac. If it's less than 0, that means you've got the square root of a negative number. And the square root of a negative number is going to be 2 complex imaginary roots. So examples of those answers might be x equals 5 plus or minus 2i. Okay, imaginary roots, if you get an imaginary root, your graph is not going to cross the x-axis. You're going to have something like that. Might just, it does not touch the x-axis. So you can tell what your answer should be like just by looking at the b squared minus 4ac. Notice the radical is not over it. Okay? Okay? So let's look at one. Let's say I ask you to solve. Let's do one more. Solve 2x squared plus 6x minus 7 equals 0. And let's say the author said find the discriminant first. So find the b squared minus 4ac. Remember, this is your a, this is your b, this is your c. So b squared would be 6 squared minus 4. My a is 2. My c is negative 7. 6 squared would be 36. Now multiply a negative times a positive would be a negative, times a negative would be positive. 8 times 7 would be 56. So I end up with 92. Okay, 92 is greater than 0. So is 92 a perfect square? No. So it's this. So before I ever solve this problem, I know I should get 2 real irrational roots. Okay? Okay, so now we solve it. Write the formula down. If I can do one thing, this would be it. Sub in. I would rather you sub in, because that way if you made a mistake, you might be able to find it. Okay, so x equals, so the opposite of b would be negative 6. Don't do any simplifying, just sub in, plus or minus a negative 6 squared minus 4. My a is 2. My c is negative 7. And it's all over 2 times 2. Double check. Did I do okay subbing in? Oh, why did I do a negative 6 there? There's no negative there. Yep. Yeah, but I made a mistake. Good check. Okay. Okay, so x equals the opposite of 6 plus or minus 36 plus 56 all over 4. X equals negative 6 plus or minus square root of 92 all over 4. 92. It's even. Divide by 2. Goes in there. $46. 46 is even. Divide by 2. 23. Here's your perfect square. 2 times 2 would be 4. So we can split that up into 4 and 23. So x equals negative 6 plus or minus 4 times 23. And it's all over 4. Two on the outside. I don't want you to skip that step. I want to see the steps. Okay? Now go one more step. x equals negative 6. Actually, we have 2 more. What can you take out? 2 radical 23 all over 4. Now, don't get all the way to there and miss it. You have to say what divides into all of those. 2. So, x equals 2 goes into negative 6. We have negative 3 plus or minus. 2 goes into 2 once. So 23 all over 2. Final answer. Negative 3 plus or minus radical 23 all over 2. Is this answer 2 real irrational roots? Yeah. So you know before you ever look at by looking at the discriminant, it's 2 real irrational roots. Don't get all the way down to here or here and miss it because you don't know how to simplify it. Take time to break down the 92. You know it's even. Okay, you got to go through your divisibility tests. Okay. Okay. The rest of it, there's no assignment for tomorrow. The rest of it is your review.